Financial algebra, we're going to cover a section that doesn't really have any math involved, but it is a part of statistics. So we're going to, not statistics, but we're going to go over some information that does involve some math, but you're not calculating really anything. And so some vocabulary. If you invent something or create something, the first term you want to know is patent. You get a patent on your product, and this basically claims ownership of the idea, so no one else can claim it was theirs. A trademark, like we all recognize the Nike logo and the Instagram logo. Like these are logos, fonts, or phrases that are specifically associated with a specific product. Like just do it, that's specifically related to Nike. That is a trademark. Bias. How we word something is very important for surveys or for samples. And so a bias is something that has an unfair influence on the results. Questions must be worded in an impartial way. Then there are two kinds of studies: experimental study and observational. Experimental is when a variable's been manipulated to see if it has an effect, like testing different types of pharmaceutical drugs or testing different products. So one group has been manipulated and when the other hasn't. Versus an observational study, you are simply just comparing. You can't alter the comparisons and you're just recording the info that you observe. So we're going to do some of each. I believe on your homework you'll just be selecting bias or unbiased, observational, experimental, very little numbers involved. So number one, we have to decide whether these questions are biased or unbiased. And so it's really, really careful on the wording. Do you think a person who doesn't vote is irresponsible? That would be, I'm going to put, I think that could go other way, but unbiased. Do you agree or disagree with the fact that eating in class is not permitted? That's unbiased. Don't you think? Now this phrase right here is a little misleading, that Mr. Menschel should let us use calculators more often. This is misleading because it's already convincing you that you should say yes. So this is bias. How would you describe the car? That's unbiased. Do you feel that hockey is more exciting than tennis? It's already kind of leading that way, so this is bias. Do you feel fast food restaurants are part of a healthy diet? I would say this is bias because it mentions healthy diet. All right. A cosmetics company is deciding whether or not to modify a lipstick product they manufacture. They need to do some research. They want to test if women react differently to medicated lipsticks. So they randomly select 500 women and randomly assign them to two different groups. One uses medicated lipstick and the other uses a non-medicated lipstick. Is this observation or experimental? I would say this is experimental, because they're manipulating the outcome by giving one group one product and the other a different. And I'm going to go back, so I'm going to kind of skip around. Number 5, a pharmaceutical company. Hold on. A pharmaceutical company, you know what? Sorry, just a second. The lipstick is observational because they are not testing to see whether the lipstick affects a specific element. Like this, they're not testing to see, does it affect the dryness of their lips? Does it affect how long it lasts? They're just observing how they react. So I would say this is observational. Number 5, though, is a pharmaceutical company that's testing a new drug to see if the effectiveness on lowering blood pressure is superior to the old drug. So they randomly select 2,000 people. They split them into two groups. One takes the old drug and the other group takes the new medication. This would be experimental because the blood pressure is the variable. That's what's being affected. So it is experimental. All right. Number 3. So teaching you how to use this chart they gave you. It was the random number generator. You have one in your book. I have a smaller one here. A music school needs to test some new music stand designs. They need to select 100 students randomly from an enrollment of 719. So if they use the random number table, how many digits will they need to represent the students? So the students go up to 719. So 0, the first student, or student number 1, would be 001 all the way to 719. So in order to be able to pick everybody, they need 3 digits, because you are selecting out of 719 students. So you're going to need 3 digits. So if they use the number table starting on line 10, what are the numbers of the first 5 students who will be selected? So number 10, I'm going to circle the first 3 would be 946. And we'll talk about that in a second. Now, 946, they only have 719 students, so I'm not going to use 946. Instead, I'm going to go to the next 3 numbers, which is 069. So student number 69. And then next, I have 788. 788, but again, I only have 719 students, so there's no student that has been numbered. Like if you were to take all the students and assign them a number 1 through 719, no one's going to be assigned 788. Next, 252. And I show here it wanted the first 5 students. So far I have 1, 2. So I'm going to keep going. 252, 960. Again, they only have 719. So here's the next one, 146. 056. So I've got 1, 2, 3, 4. 695. And so there are the first 5 students. So the answers would be student number 69, 252, 146, 56, and 695. All right, let's try another one like that. Number 6, the Forever Tread Tire Company manufactures bicycle tires. They have developed a new type of tire that they plan to test on 200 customers' bicycles, randomly selected from 8,476 customers. So if they start, they're going to need 4 digits, because I could choose person 1 all the way through 8,476. So I need 1, 2, 3, 4. Either way I slice it. So line 18. And I'm looking for, here's line 18. I can't see that. Line 18, and I need, what will the numbers of the first 3 customers be? Okay. So my first 4 numbers is 9,996. And I can't use that, right? 9,996, because it only goes up through 8,476. So I'm going to move down the line. The next 4 is person number 1,293. Okay, 4,656. And next one, 4,658. Those would be the first 3. Why will a match pair design be better than a complete randomized? Everyone rides a bike differently, right? How they sit on it. And so the best way would be to have one person use both types to get a better comparison. Okay, back to number 4. A random group of 90 gas stations from the 121,000 gas stations in the United States is to be taken using the random number table. So how many digits will be needed to assign to each gas station? Well, I have 1, 2, 3, 4, 5, 6. So 6 digits so that everyone's included. Would it be possible for the random sample of 90 gas stations to contain only California? Yeah, because there are definitely more than 90 gas stations. Would it be probable that they're all from California? No, not using a random. The fact that you would choose 90 from all over the United States, it's not very probable that they would all be from California. Is it possible? Yes, but the probability is very, very, very low. Would it be possible for the random sample of 90 gas stations to all be from the same brand? Yes, if there's 90 of them, like a Shell or a Chevron, there's probably 90 Chevrons and 90 Shells, so that would be pretty easy. Would it be probable? No, because again, we're going to use a random number generator. I'm going to skip number 7. All right. So, finally, number 8. And when you are using the normal bell curve, we're going to need page, in our book, page 718 and 719 for the z-score chart. So number 8, if they number batteries 0, 0, 1, and 900 and start on line 3, what are the numbers for the first 5 batteries? So here's number 3, first 5, I need 3 digits, so 899, 343, 506, 391. Let me record those. 899. 343, 506, 391, and I need one more. The very next number is 182. If the lifetime of the new batteries in a flashlight is normally, so in a z-score, you calculate it by your data minus the mean divided by your standard deviation. So in this case, they're saying that what percent of batteries will not meet the standard of lasting 100 hours. So 100 hours minus the mean of 110, and there's my standard deviation. So minus 110 divided by my standard deviation. I get negative 10 over 10, which equals negative 1.0. So I'm going to look this up on page 718 to 719. Okay, so let me grab our book and go to that page. And here's negative 1.0, and so I get 0.1587. So 0.1587, which as a percent would be 15.9% of batteries will not last 100 hours. Okay, and that concludes our notes.